In this video, we'll look at the process of determining a sample size for a two-class concentration-based sampling plan using the calculator in the two-class concentration tab. As usual, cells that accept input are shaded in orange, and we have several areas in this calculator as follows. At the top is an area for specifying the sampling plan, including the sample size, the acceptance number, the standard deviation on the log scale, and the microbiological limit, little m, also on the log scale. The corresponding OC curve is shown at the bottom. There's also an area for a point of interest, which allows you to calculate the sampling plan's probability of acceptance and rejection for any mean log 10 concentration that you might be interested in. And we have a separate video showing you how to use this. And there is an area for providing a consumer's and producer's risk point. And there are also several other graphs that provide some further information. Now let's have a look at developing a sampling plan from a purely statistical basis that meets a consumer's and producer's risk point. The first thing we need is a reasonable estimate of the standard deviation. Now you may be able to obtain such an estimate from either historical data, from the published literature, or by collecting a few sample units as part of a pilot stage. We also need to decide on what the unacceptable limit, the little m, should be, which is basically a business or risk management decision rather than a statistical one. So for this demonstration, let's assume that the standard deviation is 0.8 and that the microbiological limit is 2, both on the log scale, just like we have here. Next, we need to specify the consumer's risk point. Now this is done by providing a worst case mean log 10 concentration and a corresponding probability of acceptance. Let's say that we have values of 1.5 and 5%. And entering these into the calculator also provides us with the corresponding arithmetic mean, on which is then also shown, this consumer risk point, using the arithmetic mean on the OC curve here. Now the current plan with n equals 5 and c equals 0 gives a probability of acceptance of 21.3%, which is shown here under the actual heading. The value is shown in red because the plan does not meet the consumer's risk point that we have specified, which, remember, was 5%. And we can see this also from the OC curve because the OC curve lies above the consumer's risk point. And for the consumer's risk point, we need the OC curve to fall below, so that the actual probability of acceptance is at most 5%. In order to get the OC curve to be lower and produce a smaller probability of acceptance, we need to increase the sample size. And we do this by trial and error. So as we look, we get a smaller and smaller probability of acceptance. And when we have a sample size of 10, the actual here turns green because our actual probability of acceptance is now less than the maximum that we can tolerate as specified in the consumer's risk point. Now, at this point in time, you're basically finished, unless, of course, you say that this sample size here is too large for practical reasons, which means that you have to relax the consumer's risk point, either by increasing the mean concentration or the maximum tolerable probability of acceptance, or possibly by increasing both of them. The other thing that you might, of course, want to look at is the performance of the OC curve at lower levels of microbial contamination. And in fact, it may be appropriate in some cases to also specify a producer's risk point. So for the purpose of this demonstration, let's consider that we are interested in a producer's risk point with a mean concentration on the log scale of 0 and a probability of acceptance of at least 95%. So we want 95% or more for the producer's risk point. We now see the producer's risk point on the OC curve here, and the current sampling plan that we have produces an actual probability that is only about 94%, or just slightly less than the 95% that we have specified. You might decide that this is close enough and that we shouldn't do anything else. Alternatively, if you do want this actual probability to be greater than 95%, we have to then increase the acceptance number. Now, this has the effect of shifting the OC curve to the right, and while the producer's risk point is met, the consumer's risk point is no longer met. In order for our sampling plan to meet the consumer's risk point, we again need to increase the sample size, and again using some trial and error, and you might be able to use slightly larger steps than I'm using here. We find that a sample size of 16 and an acceptance number of 1 will satisfy both the producer's and the consumer's risk point in this case. In practice, this approach may need some iterations. You may have to increase the acceptance number to 2, increase the sample size again, and possibly increase the acceptance number more until both the producer's and consumer's risk point are met. But of course, keep in mind that you may also need to revise your consumer's and producer's risk point, or in fact both of them, to achieve a sampling plan that has a sample size that is small enough to be achievable in practice.